like it is. All right, so today we are talking about, well, the title of your notes are manipulating equations. What that means is we're going to be rearranging the order and the placement of terms in equations. So if you look at the board, the whiteboard up here, I've got the distance formula. Distance equals rate times time. Is that formula new to anybody? We've all heard that, right? Never heard it before? No. Something I'm sure you may have forgotten it, but that's something that's introduced in pre-algebra. Algebra is a very common formula. We use it in linear equations, but we also use it in the unit on literal equations, which is our unit today. We've titled this manipulating equations. That just means we're rearranging, writing the equations in different forms. But that is actually the literal equations. And you did that in 7th and 8th grade. You did that for sure in Algebra 1 and Geometry. You might have forgotten when you did cover that, but this would have been an equation you used in all of those kind of topics. So here, this says, so the distance equals our rate that we're traveling times the amount of time we're traveling, and that will give us our distance. So in this form, the distance formula, Hunter, you understand that better? You're not feeling well, are you? No. Do you need to go to the clinic? All right, guys, stay awake, okay? Unless you want to sit in the sitting, yes, you can, if that helps. So if we know the rate and time, this is a great form to have the distance formula written in. Because we just plug in the rate times time and we get our distance every time. But let's say we don't know the rate and time. Let's say we know the distance and the time. It makes more sense for this formula to be written in terms of the rate, or have the r by itself. So in this case, we can isolate the r by dividing both sides by t, and now we could say, we know our distance, we know our time, we're just going to divide those each time and we'll get our rate. So if our distance changes or our time changes, it's going to change our rate. So we can do the same thing with this formula. If we're like, oh, well, I know my distance and my rate, now I want to know how long that's going to take me. And that's a pretty typical thing when you're on a road trip. You know how fast you're going to be driving. You know how far you have to drive. So you want to figure out how long it's going to take you, right? So if we solve this for the time, to divide both sides by r, then we know that the time is equal to the distance divided by the rate, right? So we can manipulate these equations and write them in different forms that work better depending on what we know and don't know, or what we know and what we're looking to know, okay? So that's what we're talking about today. My board's down. Okay. We're going to do a quick review on solving equations. Hopefully this is very boring for all of you, but I will assure you there is at least one person in here that this is not super easy for, and this is why we review it. Also, the steps we use for solving equations are the same steps that we use for manipulating equations. So let's go ahead and get started. Can someone read the equation number 1 for me? Make sure you're reading all the operations when you read it. Can you read that equation for me, Liam? So there's only one operation there, we're only adding on the left side? Are we doing any other operations? What do you think? Are we doing any other operations?
2 times x.
Negative 2 times x plus 11 equals 15, right? So when we're solving an equation, we're isolating the variable. We can solve any equation if we only have one variable, right? We are manipulating that equation, even though it's not a literal equation. We are moving things around to get the variable by itself. In order to do that, we need to know what's happening to the variable. So in this case, when you're writing what I'm writing, we're multiplying the variable by negative 2, and we're adding 11 to the variable. It's important to know what's happening to the variable, because that's how you know what to undo to get the variable by itself. So now we know we need to undo multiplying by negative 2, and we need to undo adding 11. You guys remember which one we need to undo first? So adding, right. So 99, most of the time, I won't say 99 times out of 100 because that's, I'm definitely making up that stat, but most of the time we undo adding or subtracting first. There are a few exceptions to that, and we'll talk about that. So we're going to undo the adding by subtracting 11 from both sides. So negative 2 times x equals 4. So 11 was added to the term that had the x. Now we've got to, we undid that by subtracting. Now x is being multiplied by 2, so we're going to undo that by dividing by negative 2 rather. So negative 2 divided by negative 2 is 1x, or x. 4 divided by negative 2 is negative 2. So if I plug x, negative 2 is the solution, because if I plug in negative 2 for x, or replace x with negative 2, my equation will be a true statement. The left side will be equal to the right side. Negative 2 times negative 2 is positive 4. Positive 4 plus 11 is 15. So we know that the left side equals the right side. That is the way we can check to see if that is actually our solution. All right, any questions? All right, so the next one has a fraction in it. Most of the time, I'm going to suggest that you get rid of a fraction, especially if you have a fraction that's going to require you to add and subtract fractions. So example 2 is one of those. So if we have a fraction in an, my board's not working. I'm going to try turning my word off and on. If we have a fraction in our equation, we can get rid of that fraction. If there's only one fraction, we can just multiply the entire equation by the denominator of that fraction. If it's got more than one fraction, we can multiply that entire equation by a multiple of all the denominators. Really helping us work. It's really nice. Okay. So here, oh, actually, I'm going to write the steps up here. So we're going to get rid of the fraction, or get rid of fractions, by multiplying by the denominator or or a multiple of all the denominators. So this equation only has one fraction. Hunter, you're writing what I'm writing, buddy. This equation only has one fraction. I see if I multiply, if I distribute this fraction, I'm going to have negative 3 halves x minus 1 half. I don't mind the negative 3 halves x so much, but that minus 1 half means I'm going to be working with a fraction and a whole number, means I'm going to need to convert to common denominators, which means it's going to be a whole hot mess. So we're going to just get rid of that fraction, and we're going to multiply by 2, or 2 over 1. Now we're going to distribute that 2 to this fraction of the factor on the outside of the parentheses. 2 times 1 half, 2 over 2 is just 1. We do not multiply by what's in these parentheses, because this number gets multiplied by that. In this case, it doesn't matter because it's 1, but sometimes it'll be a different number, right? Equals 2 times 7, which is 14. So really what we have is 3 times x minus 2 equals 14. I just wrote the 1 there so you can see my process. You don't have to write the 1 there if it's going to be a factor of 1. Now we have a two-step equation. Looks just like number 1. The x is being multiplied by 3. That x term is, we're subtracting 2 from it, so we're going to undo subtracting by adding. Colby? I'm writing. You should be writing. Oh, what did I do wrong here? Did you guys see? Yeah, I wrote the problem. Yeah, I copied it wrong. It should be 1 there, right? That's why we do penciling here. You don't make a mistake, I probably will at some point. So this is going to stay the same right here. We did not multiply anything inside the parentheses. We multiplied the factor on the outside. Okay. So now undoing subtracting 1 by adding 1. That's 3x equals 15. And now we're going to divide. We've got 3x equals 15. We undo the multiplying by 3 by dividing by 3. And now we know that x equals 5. 15, 3 times 5 is 15, minus 1 is 14. Half of 14 is 7, so 7 equals 7. We know that that is a solution. How's number 3 different from the other equations we've done so far? Not two exponents. Not two equations. Not two problems. Doesn't have a fraction. Number 3 doesn't have a fraction. What's that thing called when you don't have any? Say again? 2 numbers and an x by them, but 4 has x's too. 3 is different than all other 3 because there's a variable on both sides of the equation. Right? So this one is different because there's an x term on the left of the equation and an x term on the right. When that happens, you have to get all the variables on the same side before you can start undoing anything, right? So there's a step, there's like an order that things should be done in. The first thing we want to do is if we have parentheses, we're going to get rid of them. The next thing, if we have like terms, we're going to combine them. And then the third thing is if we have variables on both sides, we have to get them on the same side. The way that we do that, anybody have an idea how we do that in number 3? Minus the 3 by 6x. So we okay, so we could subtract 6x from both sides. Probably best practice is add 3x to both sides, but your way works too, Vincent. Alright, so why would we add the 3x instead? Well, really the only reason is because we won't have negatives on our coefficient. And negatives very often lead to a careless mistake. We lose track of the negatives for some reason. So I would suggest you always add the smallest variable term to both sides. So negative 3, positive 6 is the variable term has the smallest coefficient. Let's add the opposite of that to both sides. And when we do that, we move it from here to the other side. So 9 times x plus 4 equals 0 minus 5 or negative 5. That goes away. 9, so this is times 9 plus 4. We're going to undo the adding 4. Yes. Minus 5 here. This will be 0. Always do it from left and right. If you do it in your calculator, 0 minus 5 will give you negative 5. Now we divide both sides by 9. And x equals negative 1. 6 times negative 1 is negative 6 plus 4, that's negative 2. Negative 3 times negative 1 is positive 3 minus 5 is negative 2. So each side of that equation, if you plug in negative 1 for x, the left side equals the right side. So we're going to give ourselves a couple of steps. 1, get rid of parentheses. combine like terms. Handwriting. 3, get the variables on the same side. Or get the variables on one side. And then the last thing would be to solve. And that means isolate the variable. Sometimes you don't have to do all the steps. Sometimes there's no parentheses. Sometimes there's no like terms to combine. Sometimes there's no variables on both sides, right? So number 4, there are not variables on both sides, but there are a whole bunch of variables on the left side. And there's parentheses. We're going to get rid of our parentheses first. We're going to distribute. So whatever we're not working with, we're going to go ahead and bring down. We're not doing anything to 4x plus 2x. So negative 5 times x is negative 5x. Negative 5 times negative 3, that's a very common mistake. Kids are going to put minus 15 there, so be careful. Negative 5 times negative 3 is positive 15. So we got rid of our parentheses. Now we're going to combine like terms on the left side, like terms on the right side. There's only one term on the right side, so nothing to do there. But the left side, a bunch of terms. Does anybody remember what it means to be a like term? Same variable, we need to be a little more specific. That is true. Same variable and same what? Constant. No. Like 2x squared and 3x like terms. Yeah, so answer my question. Are 2x squared and 3x like terms? No. Because, why, Sean? They have different exponents. So to be like terms, remember, the same variable with the same exponent. So 2x plus 3x is 5x. But 2x plus 3x squared is 2x plus 3x squared. You can't add those, right? Okay, so here, we're looking through, we don't have that problem. We have a bunch of like terms here, only x's. 4x plus 2x is 6x minus 5x. I've combined all those like terms to x. Plus 15 equals 18. I didn't have anything to combine my constant with. Now I'm going to undo the adding 15 by subtracting 15. And now I've solved my equation, x equals 3. Any questions? Clinton? I added, so I combined them. 4x plus 2x we can add by adding their coefficients. So 4 plus 2x is 6x, and then I subtracted 5x, right? And that 6 minus 5 gives me 1x or x. Okay? Give you a second, and then I'm going to move on. I can always come back at the end, and you can either watch the video to get it if you missed it, or let me know and I'll let you take a picture of it so you can fill in the rest of your notes at the end, but not right now. All right, we're going to move on. So in the equation column, that's the equation solving steps. In the description and reason column, that's a short description of what you did and why. You will have to do this on your homework. So this is not a literal equation. Let's actually write a definition of literal equation here. So a literal equation, I'm going to type it because my board's not working right this second, my pen. That's an equation with more than one variable. If we're solving this equation, 4 times x plus 5 equals 25, the directions are for us to solve for x. What do we have to do to solve for x? Anybody? We do have to isolate the variable, so what's the first step? Subtract 5 from both sides. That's exactly right. My pen is not working. I'm doing the best I can here. And so now we're going to have 4x equals 20. Everybody with me? What do we do next? Well, actually, it's still in our description or our reasons there. So I think the easiest way to do it is to do a step and then write what you did verbally, right? Do a step and then write what you did verbally. Remember, these are giving points, but if you don't write everything down, you will not get the free points. One blank section will give you 0 points on this entire note day. I'd like for you to be thinking while you do it, but they literally require none of that. All you have to do is write what I asked you to write to get credit. All right, so what do we do next here? Sorry? Divide by 4 on both sides. I'm going to do that there and give my pen a little bit more time to charge. I think maybe it's not charged. Divide by 4, divide by 4, and x equals 5. So for that first equation, it says solve for x. What am I going to solve? What variable am I solving for number 2? How do I know which variable to solve for? Anybody have an idea? Couldn't I solve for any of those variables? So they have to tell me what to solve for. Right? So in this case, they're going to tell us to solve for a particular variable. They're telling us to solve for b. Very hard sometimes to remember which variable you're solving for, so make sure you make a mark, a circle, underline, highlight. So here it says they're solving for b. I'm going to underline b. So if you'll notice, and it tells you this in the directions up here, oh actually I don't think it does, but if you'll notice that these equations are very similar. The first term is 2 factors, 4 times x. The first term here is a times b. Plus a number here, plus a number here. Equals a number, equals a number. No factors on those, right? So here we subtracted the number being added. That's exactly what we're going to do here. We're going to subtract c from both sides. When we do, we'll be left with a times b equals d minus c. And I'm going to go through and make sure I underline my b again to remind me I can't solve for the a here. If you solve for the wrong variable, then you will get the problem wrong. And just like up here now, we have to divide by that factor. The factor with the x is 4. The factor with the b is a. So dividing both sides by a, simplifying. So now we have b equals d minus c, all divided by a. So we did our steps. Now we're going to write the description of what we did. Hunter, are you with us? Y'all caught up with me? All right, I'm going to go on. If you need me to come back at the end, I will. All right, so this goes on to talk about how in the last example, the equations are basically the exact same equation, so we had all variables in one, and we talked about that already. These are steps you can use to solve or rearrange, manipulate these literal equations. And I would suggest, especially if you're not comfortable with this process, that you practice using some steps. Maybe these steps, because these steps you can have these notes on your when you take your test. Okay? So here we have z times x plus b times y equals r. What variable is this equation solved for right now?
Solve for y.
Yeah, they wanted to solve for y, but right now, it's solved for r right now. But when we say solve for a variable, it means that that variable is by itself, right? So right now, this equation is solved for r because r is by itself. But they're asking us to manipulate this equation and to actually solve for y. Wasn't it y? Yes, y. So that's what we're going to do. So now we're looking. The actual y is being multiplied by b, and then that variable term, the y term, they're adding zx. Okay? So what are we going to undo first to get y by itself? Are we going to undo the multiplying by b, or are we going to undo the adding dx? Yeah, we're going to undo the adding dx, and dx is d times x, so that gets kind of confusing, right? And remember, we have to look at how it relates to the variable we're solving for. So this variable term, this is being added to that. So we're going to subtract that minus dx minus dx. So what I'm going to have, opposites equals 0, so now I have b times y equals r minus zx. I'm solving for y, so this b that is still on the same side with y is being multiplied by y, so I undo multiplication by division. And so y equals r minus z times x, all divided by b. Any questions? All right, we have about 11 minutes. Please don't pack up till we get all 4 examples done. We should be able to get them all 4 in that amount of time. Okay? Here we go. I'll come back to this if you need me to at the end, and you can take a picture so you don't have to watch the video if you don't want to. All right. Solve for D. 1, 2, 3, 4, 5, 6, 7 variables in example 1. We're solving for D. This is a little bit different. There are 3 factors in this term, right? 3 factors in this term. So what we're saying is, what is happening to D? Well, we're multiplying D by C and E, right? And we're adding AB. So I need to undo what's being added, and I need to undo what's being multiplied. In most cases, especially in these literal equation problems, if we're multiplying by 2 variables, we can divide by those 2 variables at the same time. So this is a little bit confusing now. We're multiplying by these 2, adding, why do I undo? I'm definitely going to undo these 2 by subtracting. I'm undoing these by subtracting because I need to move the entire term, right? If I subtract AB from both sides, now I've moved that entire term away from my D. So now I have C times D times E. I'm going to rearrange these though. I'm going to write it as C times E times D. Does it matter which order I write numbers in when I'm multiplying? It does not. 2 times 3 times 5 is the same as 3 times 2 times 5, right? You do the same thing. I'm just rearranging this because I'm going to divide by both of these when the time comes at the same time. Equals F times G minus A times B. I can't add or subtract anything. I just have to write it as a subtraction expression there, right? So now I have to get D by itself. D is getting multiplied by both of those. I can divide them both away at the same time.
Wait, I have a question.
Okay? Go ahead. The order doesn't matter. We rearranged it so we can put our D all the way on the right. Normally when we're solving for an expression, we'd have an equation 2x plus 3 equals 5, right? We put our variable that we're solving for on the right, so that's all I did there. You don't have to write that one. And so now D equals F times G minus A times B, all divided by C times E. Any questions? So number 2 goes against the rule I've been telling you. I've been telling you we almost always undo adding or subtracting first, right? But if our variable's in a fraction, we're not going to undo that first. Ms. Taylor used this term. I've never used this term before, but maybe you, if you had Ms. Taylor, maybe you did. Kill the fraction first. That just means we need to get this variable that we're talking about, we need to get rid of that fraction. We could, anytime we get rid of a fraction, we're going to just multiply by that denominator. Right, so we're going to actually, the variable, we're adding x to it, and it's being divided by b. But in this case, we're not going to undo the adding or subtracting first because it's part of a fraction. We're going to multiply both sides by b first. These are going to simplify to 1, which gives me 1 times x plus y. And t times b, I'm going to write it as bt. Just we typically write these in alphabetical order. You could write it as t times b. It would be fine. We're still making sure, I forgot to indicate that I was solving for y here. Now, I can undo my adding x by subtracting x from both sides. So now I know that y equals b times t minus x. Alright? There's more than one way to manipulate most of these equations, right? There's more than one right way to do it. I'm showing you what I think is the easiest way to do it. In fourth period, I actually showed them a harder way to do it. But every once in a while, you're going to do it the harder way. You do have to know how to get it simplified, even if you don't do it the simplest way. I'm going to show you the easier way this time, though. I made a, for lack of a better term, a typo one. I wrote the wrong thing in one step. But anywho, the simpler we make it, the less opportunity we have for that kind of mistake. So if we're solving for k, let's go ahead and underline k. So we know we're multiplying k by 1/2 h, and we know we're adding 3 to that whole k term. So there is a fraction, but the 3 is not in the same fraction, right? So we're going to go ahead and undo the adding first this time. You guys see the difference in why we're undoing the adding first here and why we did it there? Okay, the number we're undoing is not part of a fraction in that same term. So subtracting 3 from both sides, that's 1/2 times h times k equals s minus 3. So far, so good? Alright, I am going to go ahead and undo these one at a time. I could do them at the same time, but I think it makes more sense to do them one at a time. So I'm going to undo, remember that I'm solving for k, so this is k, h times k, I'm going to divide by h to get the h on the other side. So those simplify to 1, that leaves me 1/2 times k equals s minus 3, all divided by, h going in, by h. So far, so good? So now, how do I get rid of fractions being multiplied by my variable here? Multiply by what? The reciprocal. Technically, we undo multiplying by dividing, right? But if you divide by a fraction, you're really multiplying by the reciprocal, just like Michelle said. So we're going to multiply by 2 over 1 and multiply by 2 over 1. If we do that, remember, we have to group that together. 2 times 1/2 is 1k. And I'm going to rewrite this as 2 times s minus 3 all over h, just so you can see my process here. But we can't leave those parentheses in it. We need to distribute in there. So it'll be k equals 2s minus 6 all over h. You with me? Any questions? Alright, number 4. Y'all caught up with me? Alright, I gotta move on because we're gonna run out of time. We're solving for y. We're adding 2x, multiplying by 3. I'm gonna subtract my 2x from both sides. This one's gonna have a couple different correct answers. I wanna make sure I get through to let you see it. 3 times y equals 6 minus 2x. I'm isolating the y, so I need to divide by 3, divide by 3. So y equals 6 minus 2 times x all over 3. We also could say y equals negative 2 times x. You need all the options here. Don't pack up. We've got 3 things here. So this or this, does everybody understand that those are the same thing?
Yes.
Great, thank you for the feedback, Tristan. Now there's one more. I think that either of these are going to be okay, and I am going to confirm that with Ms. Taylor, but there's another way you might have to be able to recognize it. Remember, this 3 here means this term is divided by 3, and this term is divided by 3. So that's negative 2 times x divided by 3 plus 6 divided by 3. Technically, these aren't simplified because we can simplify here. Y equals negative 2/3 x plus 2. So, this one, or this one are correct answers. Go ahead and scan and submit. Go ahead and scan and submit. You have a minute and a half. I'm going to check Canvas. I am trying to make sure that you are working in your best interest. These are free points. Scan and submit them. I'm going to call you by name if you've turned it in. I'm going to let the people that have submitted leave class first, in fact.